Alright, so this video is going to be about glucose homeostasis. It's the week 7 assimilation video. And so basically what we're just going to talk about is glucose and insulin and how do we get them, how are they used, why are they important. The reason they're important is we have to have sugar. We have to have energy, and sugar is energy. So we roughly have to have 80 to 120 milligrams per deciliter in our blood of sugar. And then not only do we have to have that, but there also has to be sugar in the cells. So we can't just hoard it in our bloodstream. It has to be in the cells also. So there's a balance of homeostasis between having enough sugar in the cells while still maintaining 80 to 120 milligrams per deciliter in the bloodstream. And the pancreas is what's responsible for that. Insulin is what's going to be allowing the sugar to leave the bloodstream and enter the cells. Without insulin, that will not occur. Without insulin, sugar will just continue to build up and build up and build up within the cells, within the bloodstream. So once we introduce insulin into the bloodstream, it will carry away the needed sugar into the cells. So it's going to maintain that balance of how much sugar do we need in the cells and how much sugar do we need in the bloodstream. And again, we roughly want about 80 to 120. The islets of Langerhans are the part of the pancreas that has the alpha and beta cells, and that's what produces insulin and glucagon. So glucagon we either carry in our med bags or the body makes independently. Either way, and it is what converts glycogen into glucose. So glycogen is stored glucose. If we take on a bunch of sugar, the body will use what it can, but eventually there's going to be more supply than there is demand. And so the body will start storing that sugar. And when it stores it, it converts it to glycogen. So glycogen is stored glucose. And it's stored either in the muscles or the liver, both really. So once we introduce glucagon, either medically or via the alpha cells, it will convert that glycogen into usable glucose. The beta cells do pretty much the exact opposite. They make insulin. So where the alpha cells are trying to find a way to produce sugar, beta cells via insulin are trying to find ways to get that sugar out of the bloodstream and into the cells. And the sympathetic and parasympathetic nervous system are going to stimulate either reaction, just depending, are we resting and digesting or are we fighting or flighting? And so different secretions of those neurotransmitters are going to affect different levels. Glycogenesis is when we decide to store our glucose. When we have more supply than we do demand, and we turn glucose into glycogen, that is glycogenesis. Glycogenolysis is the breakdown of glycogen into glucose. So it's the exact opposite. We have stored glucose, and now we need to use it. So we're going to go through glycogenolysis, and we're going to break down that glycogen into usable glucose using glucagon from the alpha cells. Gluconeogenesis is the generation of glucose from non-carbohydrates such as lactate, glycerol, and amino acids. So I chose lactate to just use an example. It's sent to the liver. It's converted into pyruvate by the Cori cycle using the enzyme lactate dehydrogenase. So pyruvate is then used to generate glucose. So that's just another mechanism we have to make sugar. This lactate is sent to the liver. It's manufactured, it's refined, it's converted, and we get sugar at the end of all of that. So even the liver is going to help in sugar production. And all of these are just different ways that we're going to make sugar. We want to be prepared. The body wants backup mechanisms. So we're either just going to take sugar in and we're going to straight up use it, or we're going to store excess sugar to be able to be used later, or we're going to find different acids, different lactate, glycerol, amino acids, different stuff like that through the body, and we're going to say, hey, you know what? Today you're going to become glucose, and we're going to use it for that. So there's a bunch of different mechanisms that the body has to maintain homeostasis, to maintain glucose homeostasis, because the sugar is so important. We have to have that to survive as part of homeostasis.